for the limit for R for this region, this line will be from 0 to R. But not all cases the limit will start from 0. I will show some example. And the angle should start from pole axis, which means positive x-axis. They move anti-clockwise. R move upward from the origin. So this is a tips. Okay. Okay. So next. So you have to learn this. For polar coordinate, everything should be in R and theta. No more xy. We don't want xy. Okay. So your R, y will be R sine theta. And your x will be R cos theta. Okay. R cos. Okay. And x squared plus y squared will be R squared. Remember these three and also this. Theta is tangent, R tangent, y over x. Okay. Okay. Definition. So polar coordinate of a point P is written as R theta. R, the distance between of P from pole 0, 0. The angle measured, but not always. It is from 0, 0, but the limit not always 0, 5, let's say. So it might be 1 to 5. I will show the differences. The angle measured from the pole axis to the line pole axis must be anti-clockwise. But some cases, they are negative pi over 2 to pi over 2. So I will show this also. This is for general case. Okay. So this is some derivation. You don't need to know. Okay. As you learn here, you have learned this for double integral. Okay, double integration FDA. But if your region is a circle, you have to change to the dA will be R dr dθ. Just replace the dA, everything R dr dθ, and your function xy must be in terms of R theta to use the polar coordinate. And for your cases, you don't need to know how the reverse order d theta dr. So no need. So in your syllabus, you just cover R dr dθ. No need R d theta dr. Okay. Which means the inside one should be R function of theta, R1. This is R2 function of theta. Here will be theta 1, theta 2, which is constant. It can be pi, can be number. Okay, as I told you, theta move anti-clockwise from positive x-axis. Your R should outward from pole, from the origin. Go outward. And always positive. No negative R here. Okay. Yes, I told you R d theta dr. We don't want this. Okay, just this. R d theta dr. No this. Okay. Okay, we come to example. Evaluate where R is a region inside circle. Limit is not directly given. So as I told you before, this if you want to change to the region is circle, it's easier to compute in the polar form. So this is R squared plus 1. dA will be R dr d theta. Now you want to find the limit. So limit is difficult here. So you have to use this. So try to sketch. This is circle inside. 2, 2. So for the radius, mass from here to here, which is 0 to 2. Your angle, it is, the region is everything, right? So they start from pole axis until here, which is 0 to 2 pi. Okay. Zero to 2 pi. So you can do this by your own, but the thing is, you have to familiar with you have to know how to find the limit. Okay, first you sketch, as I told you. So your angle start from here until here, and moving anti-clockwise. Your radius must be start from pole out to the region, 0 to 2. Easy. So 0 to 2, 0 to 2 pi. Your dA will be r data. So this you can simplify by yourself. See, expand first and then integrate one by one, and then you integrate respect to r first, put 0 to 2, lastly 6, 0 to 2 pi this. So I don't worry about this. But the thing is, you know how to change and correct limit and correct sketch. Ken, any question for this problem? Any difficulty for finding limit? Any question?
No, doctor.
Okay. With three other examples so that you familiar with the cases. So like this, use polar coordinate. So you have to use, for this question, actually you have choice to use the non-rectangular, but non-rectangular will be so hard. Okay, it's so hard to use non-rectangular and solve this problem. So for this, you have, okay, directly change this. You know, right? Okay. So change this to 1 plus r squared. Your dA, r dr, d theta. Okay. R is bounded circles with center radius 1 and radius 2. Bounded, which means if you have circle, this one. So bounded means this here. So this is the region. So your R should be one from pole here, another one is here. So your focusing actually is here. Okay. If you see, one is here, one is here. So this is your main R. So from 0 to here is 1, 0 to here is 2. So your R is from 1 to 2. Your angle for this region from anti-clockwise to clockwise, same, 0 to 2 pi. Can you see it? So that's why I say not always start with 1. It's according to the region that you sketch. If you see here, yeah, 1 for R, you must start from pole to here, R1. Another one is here. So you get this, because this line is represent for the bounded region. So your R start from 1 and 2. For the angle is same because it is round, 0 to 2 pi, but not always 0 to 2 pi. I will give some example later. Then you will get this. So remember, to do this, you have to use substitution method. Like u equals this, and then you'll get ln u, then answer it. So remember, you master all this. Okay, because you have learned this in the engineering math 1. But remember, integrate inside first, and that resulting answer, you differentiate respect to theta. Any question for this?
No, Dada.
Okay, so next, non-rectangular region. P. Just the same, but we have some kind of theta here. Outside should be always constant, but inside your R is function of, your R now is function of theta. R2 function of theta. Say, I saw example 2 cos theta or 2 sin theta, something like that. Can be like this. Okay. So as I told you, your angle for this one is from here, another one is from here. Okay, your radius, one is here, another one is here. So your R1 is here, R2 is here. Okay, let me see example later. Or see, we don't want this, so no need to consider. Find the limit of integration integrating over R that lies between cardioid and outside region R. So you have learned this how to sketch this in the engineering maths 1. So this is like apple shape, but move to right hand side of the x-axis, and R equals to 1 is a circle. We need this one. You get this. So this is the, they said outside R1, so it should be outside here. So this is the region. So if you see here, my R should start here one, another one is here. So this is your R. So my R here is 1, and my R here is 1 plus cos theta. So automatically your limit are 1 to 1 plus cos theta. How about the angle? The angle start from here, stop here. Another one angle is bottom. This is special case. So your angle negative pi over 2 to pi over 2. This is pi over negative pi over 2, and this is pi over 2. So this is special case because we cannot move from here to here. We don't need to consider this. We didn't consider this. So that's why you have to move one upward, one downward. So as I told you, the most important thing is to find the limit. Okay? You wait for a while. Try to digest this first. I will come back. So the As I said, there are some cases limit negative pi over 2 to pi over 2, and here is 1 to 1 plus cos theta. Okay. Okay. Use polar coordinate to evaluate this, where R is a smaller segment of a circle cut off by the line. Okay. If I draw this, this is center 0. What is center of the circle? 0. What? Tell me the center.
1.
Okay. Okay. X. Okay. So your answer will be, or R will be cosine or cosecant, something like that. Your angle, one is here, one is here. Two angles. Okay. So we have to do some calculations to get there. This is the region that you want to consider, and then you have to find your angle. Okay. Your angle is from here direct to here. Y to X is exactly 45 degrees. So, sorry, 45 degree, not percent. Okay. So your angle is 0 to 504, no problem. Okay. But for your radius, it is from this center to here. So somehow, if I draw, it is like this, from center here. So you are from 0 to something here. Okay. You can think like this. This is something weird, you know. Okay? I mean, if you have something like this, it is weird to find this radius. So that's why you have to use whatever they give. You can use this also. Y is equals to X. Okay. Okay. See that. Okay. You have Y equals to X. So this is R sine theta, R cos theta. So this is tangent theta equals to 1. Theta is 45 degrees or pi over 4. So pi over 4 is this until here. Okay. Done. Another one is you can use this. Okay. So if I remove this. Okay. I have x squared y minus 1 squared equals to 1. So from here, this is r cos theta. This is r sine theta minus 1 squared. 1. So I try to expand this. Minus 2. 1 equals to 1. Plus 1 equals to 1. Okay. Plus 1 equals to 1. So 1 plus 1, remove, and this will be r squared 1 equals to 2r cos theta sin theta. So r can be cancelled. or you can bring from the left. You have r equals to 2 cos theta sin theta. Okay. Okay. This is 2 r sin theta, so no cos here. Okay. No cos here. So this is plus 1. So no cos here. So your r is 2 cos theta here. Okay. Sine, sorry. So that's why one of the limit is 2 sin theta. You can find also from here, but logically you have to draw first so that you can see. So everything here is 2 sin theta. Okay. Okay. Okay, wait for a while. Okay. Okay. So your radius will be 0 to 2 sin theta, and your angle should be 0 to pi over 4. And then the question is x dA, x is r cos theta. And then you have to use some your knowledge to integrate this. Okay. So some you have whatever you have learned in grade 1, use here and integrate. Okay, next, changing Cartesian topology. This is one of the favorite question, okay, for the finals. So also for maybe test 2, I don't know, but this one of the favorite question. So make sure you know how to change the Cartesian topology. Okay. To do the A1, first you sketch this. So what you know that here, this is y equals to 0. Y equals to square root 4 minus x squared. Positive. So that's on the first quadrant. And then you have x equals to 0, x equals to 2. So you have this knowledge. So this is just a circle with radius 2. Okay. You see here, circle with radius 2, but only in the first quadrant, x0, x2, y0. x0, x equals to 2, y0. So this is your region. So this is so easy. Your radius is from here to here. Your angle from here to here must be positive x-axis, 0 to pi over 4. Done. Your radius from 0 to what? What do you think for the radius? Radius is always 0 to 2. Done. Limit is most difficult part. Next, other thing, cos this is r squared. And dy dx will be r dr d theta. Done. Then you have to know how to integrate. For this case, you have to use the substitution first. And then you have to know how to integrate the sign. Okay. Any question for this? This is exactly 0 to pi over 2, not pi over 4. Pi over 4 is half. Okay. So B for B, C for B. So this is x is 0, x equals to y is 0, y. Sorry, this is easier to use the type 1 or type 2. I don't know why they ask you to use polar, because the region is not circle. Okay, but okay, if the question is easier to solve by the non-rectangular region, please use that. But if the question asks you to use the polar coordinate, you have to use. You see here, you have y0, y1, x0, xy. From x equals to y, we can get 45 degrees, which is here. Okay, but the angle is not 45 at all. I mean, start from 45 and with pi over 2. You see here, this is the region. When you draw y0, y1, x0, x equals to y, you will confuse. You might confuse which region is this. Okay, if I draw this, okay, x0, which is here, xy is here, x0, y0, which is here, y equals to 1, which is here. So maybe you want to choose here, right? This part, but actually it is here, because we have more constraint. This is x0, xy, y1. y0 is only here. We don't have x equals to 1. So that's why we choose this region. And then for the angle, to start here 1, another one is here. Okay? So this is exactly 45. This is exactly 90. So that's why your angle should start from pi over 4 to pi over 2. Remember to use the radian. For the radius, here to here. So this is your radius. So you have to do some calculations. You have y equals to 1. You have y equals to 1. This is r squared. Okay, this is r squared. This is r squared sine squared. dy dx r dr theta. But you have to know the angle here, the radius here for r. So to find the radius, you can use y equals to 1. What is y? R sine theta. R y equals to r sine theta equals to 1. Your r is 1 over sine theta. 1 over sine theta will be the cosecant theta. So your r is from 0 to cosecant theta. Your r is moved upward. So your r is 0 to cosecant theta, or you can write 1 over sine theta. Your angle is pi over 4 to pi over 2. Okay, then from this question itself, this is r squared sine squared theta, this is r squared. So you can cancel the r squared, left with sine squared theta. So remember to differentiate this respect to r, this is just a constant. And this is, we have r squared, r here, so it become r squared over 2. And then you can cancel whatever it is and you get the answer. Understand this? Do you have any question? Any question?
No.
Okay. So next. Application of double integral. Okay, application is nothing. Area is double integral 1 dE. Remember, area is double integral 1. So dA can be rectangular, non-rectangular, or polar. Rectangular, non-rectangular, or polar. Volume, double integral fxydA or zdA. Volume is double integral zdA or fxdA. Again, the dA can be r theta. Can be non-rectangular region or rectangular region. That's all. That's all. So remember, if they ask you to find the volume of the region, they use this formula. They ask you to find the volume of a solid, you find double integral fxdA. Another one for triple integral, next chapter, chapter 3, part 2, volume will be triple integral 1 dV. For triple integral, the minimum should be volume, no area. Okay, okay wait, this is just an example that we have learned. So find the area of a region, which means double integral 1 dE. So you can use type 1 or type 2. If you sketch this, you will get this. Okay, you can use type 1 or type 2. So let's say I want to use type 1. So it is from here to here. So type 1, I mean, cut at x is constant. So x is from 0 to 1. Your y is from x squared to x. Done. That's all. So don't confuse with polar. You can use polar also, but polar will be difficult because the region is not a circle. Yes. So inside is 1. So you get inside first, will be get y. With respect to y, we get 1. If you do type 2, you can use type 2, no problem. Okay. Find the area of enclosed by y squared and y line x plus 2. So if you sketch this, you'll get this. Okay, this is some tricky question. If you see here, region enclosed by the parabola and the line. Okay, you have 2 points actually. When you use the parabola, here parabola, you will get this, right? If you x plus 2, which means this here. So you cannot choose this or this. You have to choose inside here. Okay, so you have 2 points. When you do simultaneous equations, you get 2 points, which is here and here. Okay, another one is this. So make sure you know whatever you're doing. Okay. Okay. Use double integral to find the volume. So remember, what is volume? Double integral Z. So make sure you know how to draw this. This is just a tetrahedron. This. So if I choose the region, you just choose, for volume, you have to choose one region. So let's say I choose this. Okay. So this is your Z. 0. Then if I integrate this, if I take this, and then I will draw this, and I use the formula Z. Z will be this here. What is your Z? 4 minus 4x plus 2y. You put here. And then you take the, actually you can take this part also. It's up to you. Okay, but I like to choose the x-axis because it's easier to see. You put your eyes here. Okay. So from here, if I just type 1, 0 to 2 minus 2x, how I get this? When I put this 0, set 0. 0, and then I solve for y, I get y. I can solve for z, and I solve for this. Okay. Okay. Polar non-rectangular. You have to circle r2 sin theta, r equals to 1. So 2 sin theta will be like this, r equals to 1 will be like this. So you have, this is a little bit difficult. To find the limit, for this question, okay, you have to use polar, right? This is they ask you for area. So area is 1 dA. dA will be r dr d theta. So now you have to find angle for radius for r and the angle itself. So for radius, if you see, if I start here to here, one radius, another one here. So actually you are finding this radius. Why I choose this segment? Because they said inside r equals to theta and outside r equals to 1. I don't want the region outside r equals to 1. Okay, so here r1, here r2 sin theta. So for sure your r is 1 to 2 sin theta, easy. But how about the angle? Angle is difficult now. You have one is here that is expected to this region, another one is here. So your angle will be one is here, that is pi over 6 or 30 degrees. Another one is here to here, which is pi minus pi over 6. This is difficult part. So your angle is pi over 6 to pi over 6. If you give a wrong angle, you will end up with wrong answer. So you will get very less marks. Remember that. Any question for this? You might confuse with not rectangular with polar, but you have to get used to, okay, to understand it. Okay, I skipped this question because it's not so important. So there are some example, you can do it by yourself. Okay, here your r is from here to here. So you have to know what is the radius of this. If they given in the question, not given. So you have to solve. Solve for that, you get cos theta. Your angle from 0 to pi over 2 exactly for this region. Focus on this region. So you have to know two things: r from the pole, theta anticlockwise from the x-axis. Only that. Find the volume. So volume double integral ZdA. This is just a cone, I think. This is a cone. Okay. So they ask you to find the volume below the cone, above the xy plane, which is here. So make sure you already master chapter 1 to answer this, because your test 2 will cover chapter 3 only, double and triple. So below the cone and inside above the xy plane, which means it is this part. Okay, so if you see, put your eyes here, you will get a circle. So again, if this is 0 to 2 radius because of this, and then the angle will be 0 to 2 pi, easy. And then your z is this. So this is just r squared. Square of r will be r. And then we have r dr d theta. Yeah. Okay. This is just what we say, just exercise, revision. Okay, any question for this? Anything that you not understand? If you feel that you can't imagine or you can't see the sketching part. Is it okay?
Okay, Nada.
Okay, next will be the application double integral as mass, center of mass and moment. Okay, this is also important. Lamina is a solid that is sufficiently flat to be regarded as two-dimensional. Density per unit, mass per unit area, mass quantity of matter in a body, mass of moment of mass will be tendency rotation about the point. Positive movement will be clockwise, negative movement will come to clockwise or anti-clockwise. So this is formula for mass, double integral density times dA. Moment of mass will be mx. This is just a notation, not differential m with respect to x. Remember. So mx will be double integral y. You just put y times with the density. My will be the moment of mass at y-axis. Double integral x times density. If the density equals to 1 or constant, we call them centroid. If not, we call moment of mass. The formula for the center of mass will be mx over m, my over m. This is for x-axis, and this is for y-axis. If the density is constant, the xy is called centroid. If centroid of mass lamina will be this formula. So this is, remember your x bar is mx over m, my over m, right? My over m. So this is my, as told here. Mx is this. M here. So the bottom part will be always the same. So if density is the constant, we can put it as the same, just like this. Okay, this is a formula. Okay. See this example. It's just applying the formula. Okay. What you have here, a laminar density, they give the density not the constant. Okay, occupies a region R bounded by the parabola and the line y equals to x. Okay, find the mass, center of mass. So formula for the mass is just this. Center of mass is this. Okay. Okay, solution. First, sketch these two regions. What do you get? If I sketch these two things, this is something. Two minus, so this is will be square root 2 y equals to x will be like this. So which one is bounded? 1 or 2? This is what is the shared region. What do you think? R is bounded by the parabola. R is bounded by the parabola, and the line y. Which one you prefer? Here or here? Which one? So the region should be here. You don't miss the region. So find the mass. Okay, remember, if you do this, you have two things. They can confuse you. We have the limit here and the limit here. So to find this limit, to find this intersection, you have to do simultaneous equation. You have to use the simultaneous equation. So if I find the equation, how about y equals to 2 minus x squared, y equals to x. So I can write as this. So this is x squared plus x minus 2 equals to 0. This is 2, this is 1 plus minus 2 plus 1. No, plus 2 minus 1. So what I have here, so you have x equals to -2, x equals to 1. So for sure here is, this point will be -2, this point will be 1. So your integration should be from -2 to 1, not square root 2 to square root 2, negative square root 2 to square root 2. Because this square root 2 is for this and this. If you can see properly, this and this. So this is some tricky question. So that's why you have to integrate from -2 to 1 because of the simultaneous equation. So if I use type 1, cut like this, so this is y equals to x, and this is y equals to 2 minus x squared. That's why like this. Why x squared? Because the density is x squared. Understand? This is for mass. Second, for moment, you have to find two things because they want center of mass, right? Is the question? Yeah, center of mass. Center of mass is mx over m, my over m. You already find this. You find to my and mx. We left my and mx. So my, the formula is here. my will be this double integral x times. This is here no x. Mx is y delta y, double integral. Mx y delta y, delta xy. So just you already find the limit here, right? You don't need to find again and again. Just copy the email, the limit, and just follow the formula y x squared because we have density, right? So then you have this mx, and then for my also the same thing. X delta x, your delta x will be x squared. X is the formula itself. So, and then you have this 2 point. So this point is actually is at the, let me see, is at here something. Okay. Yeah. Okay. Which is negative 1.1, 0.41. Negative 1.14, negative 0.41. So the rotation start here. Okay, the turning point start here. Okay. Okay, use the bend example. So it's just the same. You have to sketch this first. Find the mass of lamina. So first you have to find the mass. Second one, you have to find the mx and my, and find the center of mass. Constant density, no. The density is equals to y. Constant density means equals to 1. Okay, it's just the same thing. Try first by yourself, or this the solution is already here. If you don't understand, just contact me. Okay. Okay, lastly, second moment of lamina, or the moment of inertia. Okay, moment of inertia for x is double integral y squared delta xy. The same thing, the integration is same thing. If you see, this is the differences. If you see for the moment for x, y delta x. Initial for x, y squared delta x. Moment initial for y, x squared delta y. And we have an extra moment initial at z, which is you have to plus these two. X squared plus y squared. Only that. Okay. So if they ask you to find the moment of inertia at x and y, you use the formula Ix. But firstly, you have to draw the region, y equals to x, x equals to y. You have to know how to draw. Then it will be more easier to you to solve. Okay? Ken, any question?
No.
I will give this note to you. So if no question, I will stop here. Okay, tomorrow will be chapter 3, part 2. Do you have the note? Chapter 3, part 2? Triple integral. I think I already upload, right? So I stop here and thank you and good morning. Assalamualaikum.
Thank you, Doctor.
Thank you, Dada.
Thank you, Doctor.